Hello everyone. Welcome to another lecture on distributed networks. In today's lesson, we are going to continue our discussion into wide area networks from the previous lesson, and we are going to talk about some of the connectivity technologies and some of the ways how we can connect to wide area networks. So, as we discussed in the previous week about the need for wide area networks and why we may want to have wide area networks, and there we also briefly touched upon saying the type of connectivity that we may choose for wide area networks will depend on a number of factors such as cost, availability, the necessity, and so on. So, today we will look at some of those things. So, when we start thinking about wide area networks, one of the main types of networks that we said we can come across is point to point networks. So, these are the type of networks that will be established between two entities going through the service provider network, but essentially having a point to point connection. So, when we think about the wide area network part, which is owned by the service provider, and the local area network part, which is owned by the organization or the enterprise that we are working with, the point to point network will be about connecting these two LANs, and the in between connection is what we are going to get from the service provider. So, essentially, we will lease that particular service and particular connectivity from the service provider, and then we will have that connectivity. But the main advantage of having such a connection, such a point to point communication connection, is that we will have this connectivity active and available all the time. So we will have to pay for that connection. It will be managed by the service provider as part of their network, but it will be available to us all the time. So that is one of the main points about having point-to-point communication links. So if we look a bit further about these point-to-point links, we will use them when we want some form of dedicated connections. If our requirement is having dedicated connections, permanent dedicated connections, we will go for point-to-point communication links. So what we would have is it will establish a pre-established WAN communication path between the two remote locations. Between the two remote locations, what we are going to get is this dedicated connection. So even though the path may still go through the service provider network, it will still be a dedicated connection allocated to the particular organization. This can even be going beyond geographical limits, going across multiple geographical boundaries, such as different cities or even different countries, then passing through a number of different service providers. You may connect to one service provider in one city and another service provider in another city or country. This doesn't even have to be land-based connections. When we think about things like, say, from Sri Lanka, we are connecting to some other country, we are anyway have to go through a undersea fiber optic cable. So that is there. But one of the main factors to consider is, given these are dedicated connections, all the connection, all the infrastructure is only being used for that particular organization. So then when we compare that with shared services, this is going to be significantly costly. It is going to be very much expensive. But if the constant availability is what we are after, the dedicated nature of the connection is what we are after as an organization, maybe for certain voice over IP telephony type requirements, certain video conferencing requirements, and if those requirements can't be satisfied through available shared connection technology, so even if we can have shared connections and that is not catering to the requirements, catering to the needs that we have, then we may go for some of these point-to-point dedicated connections. So when we think about these point-to-point connections, most of these connections are going to be in the form of serial connections. So what we are going to have is serial communications. So this is something that you would have done very much covered in one number of your previous communication modules in data communication module. So this is something that you have covered pretty much. But the main thing to understand here is, depending on the different technologies, different carrier technologies, and different things may be available in different places, like say North American, the European, then the optical bandwidths may have different standards, and based on these different standards, they may support different speeds, different bandwidths of communications through those links. So then another thing that we'll have to think about when we think about wide area networks, the connectivity of wide area networks, it is about WAN encapsulation protocols. So this is where the information that is being forwarded onwards from the local LAN networks into the service provider network will have to be encapsulated in a suitable manner so that they can be passed on through the WAN network. So there should be a suitable layer 2 protocol that can encapsulate this information and pass on through the network. Again, there are a number of common standards here, common WAN protocols here that are commonly used when we want to use these things. There are some Cisco specific or particularly used in Cisco devices when we are establishing particularly things like HDL, like leased line connections, where we have all Cisco devices, or when the connection is between two Cisco devices, we can use protocols such as HDLC. We can use that. Then another common and another popular protocol that we may come across is PPP. So again, this is something that will provide connections between router to router, and also sometimes router to host, host to network connections. And this can be done across synchronous or asynchronous circuits. Again, this is something that we have discussed previously. One of the main aspects of PPP is that it has some form of security mechanism implemented, so that is there. So those are the sort of common standards that we may come across these days most of the time. But other than these, we can still come across sometimes SLIP, or serial line internet protocol, which is largely displaced, and PPP is the one used in that place. Then we used to have, not anymore unless there are some legacy networks, things like X25, link access procedure, or frame relay, or ATM. So these were other communication standards protocols that existed previously, not the most commonly used standards anymore. So let's briefly look at HDLC encapsulation. And HDLC encapsulation is an international standard, an ISO standard. So it is developed as an ISO standard. But then there is also a Cisco variant of HDLC, which can only work with Cisco devices. So we can use the standard HDLC in when we are connecting between any sort of devices, but if we are using Cisco devices, and then there we have the option of using the Cisco specific version of HDLC. There's like mainly a little bit of difference in terms of the encapsulation of the frames. There's like an additional component added in the Cisco variant, but other than that, they are fairly similar protocols. So when we think about configuring HDLC in a Cisco device, we will go into the interface, we'll go into configuring a particular interface, and there we can establish the particular encapsulation standard. So then what will happen is, if that particular interface is connecting to another device, then it will use the Cisco HDLC, and if we are connecting to other non-Cisco devices, it will use PPP there. But the basic idea what we are trying to do is, we will go into the interface and we will specify all the connections going out, all the communication that is going out of that interface will have to be encapsulated with HDLC. Now let's also briefly look at a PPP and how PPP works. The idea behind PPP is, it can be used in a variety of situations. So we can use PPP when we are establishing point-to-point connections, but when we are establishing these direct connections, but using a variety of different ways, whether we may use it across serial cables, phone lines, trunk lines, cellular communications, other type of radio links, fiber optic links. Even you may come across PPP in LTE based broadband connections and things like that. So PPP is a fairly commonly used mechanism that we can have. So we will particularly use PPP if we are connecting to a non-Cisco router, if that is what we want to do. And when we think about PPP, it has three main components. We will have a framing, something similar to HDLC, a framing which can be used for transporting multi-protocol packets over these point-to-point links. And then we will have some form of an encapsulation mechanism there. Then we also have what is called a link control protocol, which will be dealing with establishing, configuring, and testing the link connection. So that is mainly for link controlling what is happening with the link. Then we will also have network control protocols. This will be about establishing and configuring different network layers. Things like we can have an IPv4 control protocol or an IPv6 control protocol. So these can again run above the layer 2 environment. So PPP, when we look at PPP, it is built on a layered architecture. So we will have the synchronous or asynchronous physical medium, the physical layer in the OSI layer, the bottom one. Then we have the data link layer, which is where we will have the link control protocol. And then on the network layer, we will have the network control protocol. So PPP follows or adheres to the OSI model, and then it implements different components at different layers there. But when we try to establish a PPP, particularly LCP and NCP are the ones that it will have to be established. And when we think about the links, we will need full duplex connectivity or full duplex circuit so that we can send and receive information on the link all the time. but it can be in dedicated or switched networks. So there's no requirement that it has to be dedicated or switched networks, or even whether it has to be synchronous or asynchronous networks. So again, it can work across a variety of network situations. So if we particularly look at the link control protocol of PPP, so the link control protocol is mainly dealing with establishing, configuring, and testing the data link connection. So it will be established at the data link layer, and that is the main role that it is doing, and it will be responsible for establishing that point-to-point link. And in a way, the LCP is the one that is going to be maintaining or setting up and maintaining the WAN link or the WAN data link, and then that WAN data link is going to be used by NCP, the layer above, to do the communications there. So after the link is established, then LCP is the one is also going to do the encapsulation of the different formats depending on what is the encapsulation that is needed, and additional things such as authentication, compression, error detection. So all the data link layer activities can be established at that point as well. So when we go a layer above into network control protocol of PPP, here what we have is it can allow different network layer protocols to operate across the same communication link. So that is, we can establish a single data link layer connection, a point-to-point connection, and through that same connection we can have some IPv4 communication happening and some IPv6 communication happening, and all of these things can happen at the same time. So at the NCP level, it will include some additional sort of ways to differentiate between those different network layer protocols, and then the encapsulation can happen according to those identifiers. So let's look at an example, how a PPP session will be established. So the first phase or the first step is about link establishment and configuration negotiation. So before a link is established, one entity will have to go and request whether a link can be established. So whether certain information can be exchanged, and the link can be established. The second phase is about once the other party agrees for establishing a link, or coming into a negotiation phase, it can do a number of things. First, it can do things like link quality checks. So it can do an LCP test to determine whether the link is sufficient for those particular requirements of the connectivity. So it can do some testing and things like that to determine whether that connection is suitable. Then once that is done, then the various protocol establishments can happen. So it can do configuration negotiations, or for network layer protocols, it can have the NCP layer to do negotiations at the higher level to exchange information, and then the connectivity can be established. So after the LCP level negotiation is completed in phase 2, it can go on to NCP level communication or negotiation at phase 3, and it can do that as well. So once that session is initially established, so a session is established, then we can look at what happens at the LCP level. So what initially happens is LCP will do a configuration request, and then you will receive a configuration acknowledgement. And once the configuration is done, so the initial configuration or the initial establishment configuration is done at the LCP level, then the NCP can do its communication, or the network level communication can happen, or the packet exchanges can happen between these links. But one of the requirements that we will have is keeping this link active even sometimes when the data exchange may or may not be happening. So to do that, link maintenance frame will be exchanged. So that is, there will be certain echo requests and echo responses being sent back and forth. So that link is maintained, and while that link is being maintained, the data exchange can continue to happen. And at last, when the use for the link is completed or there's a need to terminate, then LCP can send a terminate request, and then the terminate request will be acknowledged, and then it can gracefully terminate out of that link. So what we will have is the link establishment will happen at the LCP level, then the network protocol level establishment will happen at the NCP level. Then after that, the communications at the LCP level will keep on maintaining the link, will keep on initiating or establishing the link. The maintenance of the link and termination of the link will be done at the LCP level. And while the link is actively available, the NCP level can continue to do the data exchange, the communication, the packet exchanges can continue to happen there. So when we think about setting up PPP, one of the other things that we can think about is some of the additional configurations that we can do when we are setting up PPP. So as we said, PPP supports security, and one of the ways it will support security is using authentication. So there are a few different ways that we can have authentication. We can have PAP or CHAP. So these are different authentication mechanisms that we can establish or we can enable when we are setting a PPP, when we are configuring PPP. Then we can do configuration. So we can do some compression as part of our configuration. So we can do the link to be a compressed link, so the information will be compressed, so it can be beneficial at that when we are doing bandwidth and so on, it can be beneficial there. So at the link level, we can do some compressions. Then one of the other things that we can do that can be advantageous when we want to increase the WAN bandwidth with available sort of technologies, we may double up on the links and then combine those multiple links into a single bundle. So again, these multi-link bundles is something that can be again established or configured when we are configuring PPP. Now let's look at what happens at the NCP level. So at the LCP level, it is going to establish the connection and maintain the connection and terminate the connection. So particularly the establishment and the termination is pretty much going to be done at the LCP level. But after LCP has established the link, then the routers will have to go and do NCP configuration exchanges, so NCP negotiations, and then they will have to send what is called an IPCP configuration request and a configuration acknowledgement to establish the IP level communication, and then it can do IPv4 or IPv6, depending on what we have tried to establish. If we wanted IPv4, we will have IPv4. If we wanted to do IPv6, we will have IPv6. So we will have the data transfer, and along with that, LCP will continue to do the LCP maintenance, so the link maintenance. Then when the network communication usage is completed, then we can do an NCP termination, and when NCP termination is completed, then we will go into the LCP termination. So after LCP configuration, we will go into NCP configuration, and after NCP termination, we will go to LCP termination. So now let's look at some of the ways that we would set up remote access connections to our devices. Or rather, different types of remote access connections that we can have. So one of the common types of connections, that broadband connections that we will have, that are fairly commonly used in home environments and also in enterprise or business environments, is DSL type connections, what are called digital subscriber lines connections. One of the common variant that you will be fairly familiar with is what is called ADSL or asymmetric DSL. So it provides, in a way, compared to DSL, it will provide a higher bandwidth of connection. So the basic idea here is, this is the communication spectrum or the frequency of the communication link, and the normal pots or the telephone line or the plain old telephone system, that will use only a bit of the frequency there. Beyond that, the frequency is not utilized. So then what ADSL can do is, ADSL can take up a frequency between this point after the normal usage of the POTS line or the 4 POTS communication. It can take up some of this frequency and then split some of the frequency for upstream connection and some of it for downstream connection. It can establish a number of different channels there. So we can have a number of different channels there for our communication. So this is one of the reasons, if you think about having an ADSL connection at home, for example, you may use a device, a frequency splitter, to split the connection between the telephone connection and the modem or the router device. So because we are doing a frequency separation between the devices, one parts go to the telephone link and the other one is for the ADSL data link. So with ADSL or DSL or ADSL connections, what will happen is, say we will have our computers or at home or a small office or a home office situation, we'll have the computers that are connected to a DSL modem. Then we'll have telephones and other things that will have these microfilters or the frequency splitters, that type of devices that is going to make sure that it is not going to interfere with the DSL modem frequency range. And then all those things will be combined and put on a link, and there is a limitation in terms of what is the maximum distance. So this is again a limitation in certain places where you may not get a DSL WAN connection because you are far away from the provider network switch. So you will have to be located at within this distance to have a ADSL connection or DSL connection. So then it will go to the PSTN switch, where it will be split into the PSTN network or the telephone network and the DSLAM or the data network, and the data network part of the connection will be forwarded onto the ISP part of the service provider, and this would be the telephone part of the service provider. But one of the main sort of advantages with DSL, for example, is this particular connectivity path between the office or home or office up to the service provider. This link is a purely dedicated link. It is only similar to a phone, because it is a phone line, for example. So it is a dedicated link that we will have here. So that is one of the main advantages, because it is a direct connection. It is not a shared medium connection there. Then one of the things that we discussed last week is about wireless mode of communications. And again, when we talk about WAN technologies, wireless is becoming a prominent option for establishing WAN connection, having WAN connections. And things like municipal Wi-Fi's are there in certain cities. There will be a number of common wireless access points that can be used for connecting to a wide area network, an internet-based wide area network. And one of the other most common scenario, and that is very popular in Sri Lanka as well, is LTE, which we call as home broadband and various names by different service providers. 4G LTE, for example. There used to be a standard called WiMAX, and it is largely replaced, and LTE is the standard that is most common these days. And we are expecting to have 5G in the future as well. So these are cellular mobile based wireless connections with significantly higher data rates compared to even some of the wired connectivity standards. Things like ADSL, we can have there are much faster wireless connection standards as well. Then we can also have satellite internet. This is can be a significantly prohibitive, expensive affair in many situations. But if we have some remote locations that are limited in terms of having land-based connections, either remote towns, remote cities, sometimes even things that are in in the sea, for example, a ship or a flight, if they want to use internet, so then they may have to use some of these approaches. So again, these are wireless based connections, broadband connections that we can have to connect to wide area networks. So when we think about these different standards or different connectivity options, different broadband connectivity options to connect to a wide area network, to connect to the internet, for example, there are different factors that we have to think about. Say, for example, cable internet, that is not very common in Sri Lanka, but again, one of the issues is the bandwidth is going to be shared among a number of users, because the cable lines are normally shared. It's a shared medium connection. DSL is a dedicated medium connection, but the limitation there's a distance limitation. So you can't be located too far from the ISP location. So you have to be within like 5 kilometers, 5.5 kilometers within that limit. Then fiber to home, so fiber based connections, it will require high level of installation cost. You'll have to lay cables and dig holes and all these things. So if there's no infrastructure to do that, so it can be expensive. When we think about cellular or mobile or even that type of connections, coverage can be an issue. Not every part of the country may have coverage. Some indoor parts may have limited coverage. When you have significant skyscrapers or large buildings around you, then you may have blank spots in terms of coverage. So those can be an issue. When we think about things like Wi-Fi mesh networks, again, it may not be available everywhere. It can be significantly expensive to deploy it in a larger area. So again, not an option that will be available all the time. Then satellite capacity is it is about expensive. It has limited capacity, so the bandwidth will be significantly limited. Some people say in some places the satellite internet can be even comparatively slower, similar to a dial-up connection, that type of very fairly slow internet connectivity. So what we can see here is, when we think about WAN connectivity standards, different ways of connectivity connections to broadband connections, we have to consider these factors and choose one that is more suited for our requirement. Now let's look at another concept that you may come across when you are using many of these broadband connections, what is called PPPoE, or PPP over Ethernet. So what we have here is, we will have the Ethernet packet that will be originating from the device, for example. Then it will be encapsulated as a PPP, or rather the other way around. If we will have an IP packet that will be encapsulated as a PPP, and then it will be encapsulated as a Ethernet, and we will communicate. So that is how it will be transmitted locally. So the Ethernet links, because Ethernet links don't support PPP, so it will be encapsulated as Ethernet. But then onwards, they will be transferring. After it is passed through the DSL modem, it is going to travel as the PPP packets or the PPP frames. So what we have here is, the ISP network will expect you to communicate with PPP, whereas you may not be able to communicate with PPP inside the internet. So then inside the Ethernet network, then you will use things like PPP over Ethernet as a solution there. So essentially what we have with PPP over Ethernet is, it is going to create a PPP tunnel between the devices. So because the PPP encapsulation is going to ensure that the PPP tunnel is there, but still those PPP frames can be sent across Ethernet cables whenever there are such connectivities there. So the Ethernet cable will carry on that, but inside that it is a PPP frame. Now finally we will look at one of the other important concepts, VPNs. We will discuss about VPNs in much more detail in a later course, in a later semester. But one of the main aspects of VPNs, and many of you would be familiar with using VPNs for a variety of reasons. One of the main one would be accessing content available in different countries using these geo blockers and things like that, downloading Netflix and that type of thing. So, but the main idea or the main reason for using VPNs is, most of the connections that we will have, most of the wide area connections that we will have, are going to be going through public networks, the public internet, because that is one of the cost-effective ways of having a wide area network connection. So what we are going to have is all the communication going through the internet, the public internet, a public network. So a VPN is a way of implementing a secure channel, a secure tunnel through which we can have a private communication. So we will have an encrypted communication channel between the both ends. So even if it is going through the internet, it is still secure. Nobody is able to view what is happening or what are the information that is transmitted between those two entities, because it is communicated through an encrypted VPN channel. To have VPN, we will have to have what is called a VPN gateway. So what we can have is, say we can have a VPN gateway and one of our routers here, and then the other router at the other end, the firewall or the router there again at the other end, we will have another VPN gateway. So now all the connections between these two entities can be connected through a VPN connection. But one of the other advantages with VPNs is they can also enable us connecting to much smaller networks or much smaller situations. Things like a mobile worker may connect through a VPN client on their computer to the VPN gateway, and they can still establish a secure connection, access all the things, and they can be as they are inside the local network. So they can be part of the network, but they can be connected remotely. Similarly, other small office type of environment, different types of devices can also implement this VPN. So it can be implemented as a software solution on a computer, on a router, on a firewall, or we can have dedicated VPN specific devices, what is called a security appliance, for example, to do that. One of the main advantages that we get from using VPNs is that we can use fairly inexpensive, cost-effective, high bandwidth technologies such as DSL, basic internet technologies, which are much higher bandwidth, much faster, can be cost-effective. So we can use these technologies, but still we can have, but they are internet technologies, they are public technologies, public connection, but we can still have private use, have private network connections on top of those public networks. Then another advantage is about scalability, where we can easily expand into large number of users or large number of remote connections, add a new branch office without the need to having a lease line, a new dedicated connection established. We can just establish a connection to the internet and then add a VPN channel or VPN tunnel there, and we are set up. So the scalability is an important factor there. And we can work with different broadband technologies, an important factor. Say, for example, a mobile user may connect from a cellular network, an office may be connecting through a DSL connection, the head office may be connected through the fiber type of a connection, and all of these broadband technologies can be used by different users, different situations, and they can still be part of the same virtual private network. And the main sort of underlying advantage is that it will give us the security that we need, because with VPNs we will have encryption through the communication channel, we will have authentication to establish those VPN connections, so we will have an additional layer of security than we will if we are connecting just through the internet. So that is also another main advantage of having VPNs. Then with VPNs, we can have two sort of main types of VPNs there. One is called a site-to-site VPN. So a site-to-site VPN is, we will have a router, what is called a VPN terminating device. This router is always connected through a VPN channel or VPN tunnel to the VPN terminating device at the office. For example, from your home, you have a VPN terminating device that is always establishing a connection, a VPN connection to your office. So now, if you connect your computer to this particular router, this particular device, that gateway will always point you to always send you through the VPN channel. So the VPN gateway will be responsible for encapsulating and encrypting the outbound traffic and sending it through the VPN channel. So as a client, you don't have to do anything special. You just connect to this network device and that will put you on a VPN tunnel. So that is what is called a site-to-site VPN. So anyone within this site, anyone connecting to this gateway will automatically be part of this network through the VPN. But in many situations, having a site-to-site VPN may not be practical. So, for example, if you are connecting two branches, having a site-to-site VPN is a good idea. If you are a permanently working from home worker, then maybe you may be given a VPN terminating device and you may connect through that. But in other situations, if you are temporarily working from home, or even other times when you're a mobile worker, mobile user, you may not always be connecting through the same place. You may be working from home, other locations, and things like that. So, having such a device may not always be practical. So, then what you will have is you will have a client software normally in your computer, and you will use that client software to establish a VPN connection, and then we will use that VPN connection for our communication. So, this is normally used when we are connecting individual hosts that want to connect to the company network over the internet. So here we will use VPN client software to establish that connection. Things like OpenVPN, and there are a number of client softwares that you may use that can be used for establishing such VPN connections. Then there's another type of VPN that is available that is called a dynamic multi-point VPN. So what we have with dynamic multi-point VPNs is, it is in a way we are establishing VPN connectivity between in a hub and spoke model. So what we discussed in the previous lesson, we have discussed about hub and spoke model and so on in regarding wide area networks. So in that context, we can use what is called a dynamic multi-point VPN. So here the main idea here is we are going to use some of the advanced protocols such as next hop resolution protocol, multi-point generic routing encapsulation tunnels, and internet security encryption. So we will use some of these things. Again, we will look at this in much more detail later on in the other course in the upcoming semester. But the basic idea here is we will use this as a solution to establishing hub and spoke connection, that is hub to spoke connections, and also spoke to spoke connections if we have such a network environment. And as always, there are some additional resources that will be shared on LMS, so refer to them as well. And as always, if you have any questions, please reach out to me, and we can have a discussion in one of the upcoming lessons, or if you post your questions on LMS, or reach out to me through any other medium, and we can have further discussions on those. And if there are things to be clarified further, we can go into those in a bit more detail as well. So with that, that's all for today. We will continue our discussion on wide area networks in the upcoming weeks as well. And until such time, thanks for joining in this lesson. See you. Bye.